Hello, and welcome back to my Kubernetes series. In this part of the video, we will be focusing on establishing a Nextcloud instance. We will set up several microservices and go over what they do. The instructions for setting up a scaled-out Nextcloud was published by Marko Skender in August of 2020. I want to thank Marko for developing and sharing these instructions. We will follow this guide, however, I will be upgrading a few items to the latest versions. For example, where Marko worked with PHP 7.3, I will be using PHP 8.1. That required a bit of tinkering, but we'll walk through all of these components. In this video, we will be focusing on the backend services such as session handling and hashing. In the next video, we will be working on the PHP handler and the Nginx frontend. And in the last part, we will be deploying Nextcloud and make sure we have a secure connection through TLS. That is why we deployed the cert manager and the DuckDNS webhook earlier. I will also go into my challenges with the deployment of Nextcloud, especially timeouts, and why and how I used a console to deploy this application. Let's just say I started to appreciate the fact that the console does not give me any timeouts, and I can even install large apps in Nextcloud without any issues. Alright, as we have gone through the content of this and the next two videos, let's scroll down a bit and highlight in the article what we will be covering. At first, the article highlights nicely why we deployed a database cluster in our last video. This setup was deemed out of scope of this documentation. Further, the setup of items such as building a KDIS cluster, establishing a load balancer, an ingress controller, external volumes are all not part of this documentation. Additionally, the instructions ask for a fully qualified domain name, or FQDN for short. But as I've shown in videos 901 and 902 of my series, you can actually work with dynamic DNS services. Further, the article speaks about the Kubernetes cluster domain, which by default is cluster.local, and that the instructions consider the deployment in the default namespace. That is something that I will be modifying too. Nextcloud will go into its own namespace called, surprise, surprise, Nextcloud. Okay, next in the document we see that our first item speaks about redis. Redis is a caching service and session handling. It is recommended by Nextcloud for the reason that transactional file locking is supported, whereas Memcache does not support that feature. Redis is going to be deployed as a stateful set, which comes with certain features such as scaling up from 0 and down from the highest pod by pod until it reaches its final replica count. We will not walk through the application on the website. I mentioned I changed a few items and prefer to share the configuration through the console in a bit. As you can see on the website, this YAML comes with a service definition. The file is separated with 3 dashes and then the service is articulated. Again, we will modify this file to match our namespace requirement. Ultimately, what does this deployment, or rather stateful set, do? Once deployed in our cluster, we will get 5 pods that will run as a headless service, which is indicated by the cluster IP none in the service definition. I will show a bit later, once we deployed the application, how we address this Redis instance and what their final addresses are in my deployment. These addresses will be entered into the config PHP of Nextcloud, so Redis can do its work and manage the sessions and file locking for us. Next, we are going to try to reduce the amount of connections we have to Nextcloud. That will keep our instance quick and snappy. To do that, we will be using a tool called twemproxy. If you follow the link on Marko's article, you will be forwarded to the 2emproxy GitHub, and we can see what Nutcracker, aka 2emproxy, does. It is a fast, lightweight proxy for memcached, but more importantly for us, the Redis protocol. As you can see in the description, it reduces the number of connections to the caching servers in the backend, and as such will enable us to horizontally scale our distributed caching architecture. I will not walk through this documentation here. I will walk through a detailed instruction on how I built the container and how I deploy and address Redis on the console later. Switching back to phone.pub, I will not walk through the container build process here. As I mentioned in one of my previous videos, I'm a builder user, again sorry, which I will be using to build a 2emproxy container. But if you use Docker, please copy and paste this Docker file. Alternatively, feel free to use the image on my repo on quay.io, link is in the video description. No need to reinvent the wheel. As we looked at building the container briefly, there is a YAML file we need for 2emproxy's deployment. We will rather walk through that file on the console due to the namespace changes. We have to check two files. One is the deployment itself. The other one is a config map which references the Redis instance. The last step in this backend setup is to create a service. This service is of type load balancer. If you followed my video number 7, in which we set up a load balancer on our cluster, you will remember that services of these types will request an IP address from this application. That, however, will only work if we define the load balancer class in that service definition. That is one of the differences to these instructions. That is why we will now switch over to the console and review the Redis stateful set. As I switch over to the terminal, let's enter our k8s setup folder. In this folder, I already created a Nextcloud folder, so let's go in here. And I created 2 additional folders in here for Redis and 2emproxy. So let's go into Redis, and we will take a look at the Redis stateful set. Vim redis.yaml. We will be deploying a stateful set with the name Redis into the Nextcloud namespace. In the spec section, we define a service name called Redis, and we ask for 5 replicas. We define labels in the selector as app Redis, and in the template we have the same labels defined. Next comes the spec section, in which we define volumes for the local time zone, and then we define the containers with a name master. The image is Redis. We define an environment variable, and we set this variable to true. Next, we define the ports at which the Redis instance will be listening at 6379, and last but not least, we are mounting the local time zone into the container to facilitate error analysis. Next, after the separation line, we are defining a service called Redis, and we have that in the same namespace, Nextcloud. We define a headless service with the cluster IP none, and we define the ports at which the service is listening and at which the service can reach the container in the backend. It's a TCP protocol, and we define again the selector with app Redis. This selector makes sure that your service refers back to the Redis pods, which are labeled with the same key value pair currently highlighted. You must make sure that these labels match. If they don't, the service will not be able to link up to the pods and your deployment will not work. So whatever you do, make sure these labels under the selectors, labels, and service definitions match. Cool, first one done. Let's exit with writing quit. And then let's create the namespace that we need to deploy this instance for Redis. kubectl, create namespace, Nextcloud, kubectl, get namespaces, and here is our Nextcloud namespace. As I'm ready to deploy the Redis instance, I split my screen, and now we can start watching the Nextcloud namespace, Nextcloud, to see what will happen in the in this namespace once we deploy our Redis instance. Now let us kubectl apply-f redis.yaml, and on the right hand side you should see the services starting up. Fantastic. As Redis is fully deployed, let's now switch over to my container building virtual machine and take a look at building twemproxy. In my virtual machine to build containers, I have two files I can use to build twemproxy. The first one mostly aligns with the original instructions from Marko. The second file contains the step-by-step commands required to build the container. This file is what we're going to walk through. Vim twemproxy steps. If we look at the file, it's fairly easy. We start with a Alpine latest version. We create an empty file in the etc folder called nutcracker.conf. We a.k.a. Update and upgrade the container, and we add certain packages to it. At the end, we declare all those packages to belong to a virtual group called deps1. Next, we git and clone the GitHub repository. As you can see, I also have some alternatives should I not be able to download the GitHub repo. I downloaded it previously, and then I can just copy and paste them. But as long as that works, we can continue. I declare a working directory, which will be in the twemproxy folder in the container. I auto reconfigure and configure, followed by a make command. Once all of those commands are done, I copy the nutcracker executable that's being created into the folder user local bin. I then delete the virtual group and all those packages. I set the working directory back to root, and then I delete the twemproxy download that was created by the git clone command. Then one of the last steps is I set the executable, the nutcracker executable, to use the configuration file we created in the line number 3, and I set its output to verbose. Then I define some labels and I commit to this container. And that's all there is to it. So let us execute this script. As it is literally done in under a minute, that should be no problem. And follow along as the container is built. As the container is built, let's take a look. Builder images. We do have a image built, twemproxy, and it is 17.3 megabytes in size. As this is a really nice and small container, which is ideal for containerized applications, we're quite happy to push this to a repository. If you want to use this image, please feel free, but keep in mind that the image will need a config map to work. We will take a look at this file next, and for that purpose I will switch over to my K8s master. Let's switch the folders to our twemproxy and take a look at the files. First things first, we want to start with a config map. So what are we adding to the container? It's a config map. The name is nutcracker config. The namespace is Nextcloud. We define a label as nutcracker, and then we create a nutcracker conf file. If you remember back when we built the container, we created an empty file called nutcracker conf, and this content of that file will be the redis instance that we set up earlier and that we can still see to our right. In this file nutcrackerconf, we declare twemproxy to handle redis connections. We listen on port 9999. We declare the hash algorithm. Hosts are auto ejected. Timeouts is 400 seconds. I don't know that for sure. I was trying to find this information on the twemproxy GitHub, but was not successful in this endeavor. Server retry timeout 2000, and again I assume this is milliseconds here. Server failure limit is 1, and the connections to our Redis servers. Now that we went through the configuration map, let's right and quit and walk through our deployment next. We are setting up a deployment. The name is Nutcracker. The namespace is Nextcloud. We have one replica. We are creating labels with the key value pair app and Nutcracker, which is the same as for the config map. We have the template and define the same label. Specs, we have the volumes we declare first, Nutcracker config, the file we just went through, the config map, which we have here. Then we also mount the time zone to align it with our local time zone. Next, we declare the containers, and again we call it Nutcracker. Then my repository where I stored that image. Image pull policies always. Again, this was for development purposes. You don't have to set it to always. You can also use only if not present or if not present. Then we declare the ports as 999. This port is important, as you've seen in the configuration map. We also declare port 999. Those two need to align, so make sure that they do. And then next we mount the Nutcracker conf into the folder where we stored the empty Nutcracker conf file during the container build. So we overwrite the empty file and implement the config map and will replace that empty file. And then last but not least, we're adding the time zone into our local time. Alright, that was already it when it comes to the deployment. Fairly straightforward. Last but not least, we're going to take a look at the service. Alright, the service Nutcracker again. Nextcloud is the namespace. We have an annotation with metal LB universe, but the default address pool is not called default. It's actually called IP range. That is important, as otherwise you won't get an IP address assigned. So make sure that it aligns to the right name of your address pool. Is being used to assign the IP address. The ports, again 999 on both the incoming connections to the service and then the outgoing to the container. Protocol is TCP. Selector app is nutcracker, so the service knows which container to contact or which pod. The type is a load balancer, which means it will get an external IP address. And then last but not least, we need to add the load balancer class as we declared it in our previous video. Without this declaration, we would not be able to get an external IP address. All right, write and quit. Wow, that was a lot of information. But now that we walked through these files, we can finally deploy them. We will start with a config map, kubectl apply-f twemproxy config map. Let's have a look. kubectl get cm-n nextcloud. We see the configuration map deployed. Then we will install the application itself with kubectl apply-f twemproxy deployment. We spell it correctly. That might actually work. Alright, the app is deployed and we see a container creation is starting up. Last but not least, we're going to deploy kubectl apply-f twemproxy service. Okay, the service is deployed, we get our IP address assigned, and we have our Nutcracker application fully deployed. Having deployed these services concludes this video. What is working? We have a backend for Nextcloud with a Redis session manager and the hashing through twemproxy. What's next? In the next video, we will be discussing the front end of this application with a PHP interpreter and Nginx. Until then, thanks so much for watching, and I will see you in the next video.